Now let's continue. The next function is y is equals to cot inverse x. Implies that x is equals to cot y. So here x belongs to open interval minus infinity to infinity and y belongs to open interval 0 to pi. Now differentiation of this function with respect to x is given as negative times 1 plus x square. Now for tracing the graph of this function, on x-axis we'll plot minus infinity and infinity, and on y-axis we'll plot 0 to pi, and for convenience we take pi by 2. As this function is decreasing continuously, then graph would be decreasing. Graph is parallel to infinity as it approaches infinity when its value is 0, and it touches pi if it approaches infinity. Then graph is constantly decreasing graph. So first condition is decreasing continuously. Secondly, it is again aperiodic in nature as it does not repeat its graph in the journey. Thirdly, the given function is bounded in nature as the graph follows a particular principal range. Fourthly, the function is again neither odd nor even as it is not symmetric about origin. Therefore, the similar condition varies over it as well, that cot inverse of negative times x is pi by 2 minus cot inverse x. The next function is y equals to sec inverse x. Now here x belongs to open interval minus infinity minus 1 closed interval union 1 comma infinity. Now for y it varies over 0 to pi closed interval excluding pi by 2 as this function became not defined at pi by 2. The differentiation of the given function with respect to s is 1 by 1 upon mod x root over x square minus 1. For tracing the graph of this function, the given function, this is minus 1, this is 1, this is pi, and this is 0, this is pi by 2. So for tracing the graph of this function, it does not fall in this given region. The graph falls in this given region. That it constantly increases as we move from pi by 2 to pi, and it also constantly increases when we from 1, or you can say 0 to pi by 2. So from 0 to pi by 2 it constantly increases over here, and from pi by 2 to pi it constantly increases over here. So graph tells that the given function is increasing continuously. Secondly, it is aperiodic in nature. Thirdly, given function is bounded in nature. And fourthly, the given function is neither odd nor even as the function is not symmetric about origin. Therefore, it will follow again the same condition, that sec inverse of negative times x is negative times sec inverse x. The next and the last is y equals to cosec inverse x. Implies that x is equals to cosec y. Now for this, x belongs to minus infinity minus 1 union 1 comma infinity, and y must belongs to closed interval minus pi by 2 to pi by 2 and excluding 0, as this function became not defined if we put 0 over here as y. Now the differentiation of this function with respect to x is -times 1 upon mod x root over x square minus 1. For tracing the graph of this function, we'll plot here minus pi by 2, minus 1, 1. Now again, as discussed in the previous graph, that it does not fall in this region. So the graph is constantly decreasing. So from moving to 0 to minus pi by 2, it constantly decreases. And from pi by 2 to 0, again it constantly decreases. So from the graph it's quite clear that the given function is decreasing continuously. Secondly, function is aperiodic in nature as it does not repeat during its graph. Thirdly, given function is bounded in nature, that it is bounded within the principal ranges. And lastly, the most important, the given function is odd function as it is symmetric about origin. So therefore, it will again follow that condition that f of negative x is negative times f of x. Therefore, cosec inverse of negative times x is negative times cosec inverse x. That's all for the graph. We'll continue with the rest of the chapter in the next clipping.